Hello everyone, welcome to our course in Abstract Algebra. In this session, we are going to discuss groups. Also, we will discuss the different properties of groups, explain whether a set together with an operation forms a group, give examples of group, also non-examples of groups. Now, let us define what is a group. A group consists of a set G together with a binary operation star which satisfies the following properties. 1. Associative. 2. The existence of an identity element. And the third property is the existence of an inverse element. This set, together with a binary operation star, forms a group if it satisfies the properties: associative, existence of an identity element, and the existence of an inverse element. And take note that these three properties are actually covered when we explained or when we discuss the binary operation, right? That is on associativity, the existence of an identity element, and the existence of an inverse element. Okay, to illustrate the idea of a group, let's proceed to giving an example. Now, for our first example, determine if the set of integers together with the operation addition, the usual addition, is a group. I repeat, let's determine if the set, this set here, the set of integers together with the operation addition is a group. Now, when we discuss the idea of a binary operation, we have proved that this addition is a binary operation on the set of integers. Therefore, we will no longer show that this addition a binary operation on the set of integers. So that we will now proceed to the three properties of a group. And these are: 1. Associative property, 2. Existence of an identity element, and the third one is existence of an inverse element. So there are three activities that we have to do to show whether this set, the set of integers together with the operation, the binary operation addition, is a group. The first one is we want to show that addition, the binary operation addition, is associative. Okay. Now, to show that the binary operation is associative, okay, let us take note by the definition of associativity. Addition is associative if for all A, B, and C elements of the set of integers, meaning to say that these A, B, and C are integers, A plus B, the quantity plus C, must be equal to A plus the quantity of B plus C. So, to show that addition is associative, we want to show that the quantity of A plus B plus C is equal to A plus the quantity of B plus C for all A, B, C elements of the set of integers. Okay, let's take an example. Let's assume that A is equal to 1, B is equal to 2, and C is equal to 3. Now we have to plug in these values of A, B, and C in this equation. Now, when plugging in, we have 1 plus 2, that's your A plus B, the quantity, plus 3, is that equal to, your A again is 1, plus the quantity 2 plus 3. Now, our rule is we have to simplify first what is inside the parentheses. So we will add first 1 and 2 here. Then afterwards, we will add the sum to 3. So we have 1 plus 2 is 3. Then plus 3. Is that equal to 1 plus, what is 2 plus 3? We have 5. So 3 plus 3 is equal to 6. And on the right hand side, we have 1 plus 5 is equal to 6. And of course, 6 is equal to itself. Then, okay, take note there is still a lot of values for integers. There are still integers that we can substitute, or that we can have for this A, B, and for the values of A, B, and C, but it will take us some time. So this will be enough for us to say that addition is associative. Now let's proceed to the second property. Our second property is existence of an identity element. So, existence of an identity element. And we have denoted this as letter E. Okay? Identity element. Now, again, let us recall the definition of this existence of an identity element, that for all integers, A plus, A, for all integers that matter, we have A star E is equal to A star A. Or, since our operation is addition, so we have A plus the element E, the identity element E, must be equal to E plus A, which is equal to A. Okay. So what is the value of E such that it will satisfy the given equation? So from this, we can just simplify this equation into A plus E is equal to A. And of course, if we're going to simplify this further, since we are solving for the value E, E is equal to 0. And we know that E is equal to 0. 0 is an element of the set of integers. Meaning to say that 0 is also an integer. So, the identity element exists. There exists an identity element for the set of integers with respect to the addition operation. So, check din ito. Then we proceed to the third and the last property of a group, that is the existence of an inverse. Now, Again, for the inverse, we have for all a element of the set of integers, for all a element of the set of integers, we have a plus b is equal to b plus a, which is equal to the identity element. For addition, we have e, which is equal to 0. Or simplifying this equation now, we have a plus b is equal to 0. So, solving for b, because b, we say that b is the inverse element. So, solving for b, we have b is equal to the negative of a. Meaning, if we have an integer a, the inverse is negative of that integer. Now, for example, we take some integers. No, we take some integers. Say, ang integer natin ay a is, for example, positive 1. What is the inverse element of positive 1? We know that the inverse of positive 1 is just the negative of that value 1, which is equal to the negative 1. And negative 1, as we know, is also an integer. And we know the fact that it's very elementary idea that all integers have their additive inverses. Right? So every integer has an additive inverse. So 1 is negative 1, 2 is negative 2, 3 is negative 3, 4 is negative 4, and so on and so forth. So 0 has an additive inverse of 0. Negative 1 is positive 1, negative 2 is positive 2, negative 3 is positive 3. Because when you add the element and its inverse, the sum is equal to 0. And that's our identity element. 0 is called the additive identity element. Okay? And negative 1, for example, is the additive inverse of 1. Negative 2 is the additive inverse of positive 2. And vice versa. 2 is the additive inverse of negative 2. 1 is the additive inverse of negative 1. So since these properties are satisfied by the set of integers together with the binary operation addition, then we can say that this set together with the binary operation addition is a group. And since it is a group, we can therefore denote that using this symbol for group. So meron tayong para siyang less than symbol, then the set z, then comma, then the plus sign, then the greater than symbol. This is our notation for. So ang ating conclusion ay the set of integers together with the binary operation addition is a group. And how do we write that? We can write that this way. Now, let us change this operation addition to multiplication. So from addition to multiplication, but we will still use the set of integers to be our set. Okay. So for our second example, determine whether this set here, the set of integers together with multiplication, the usual multiplication, 2 times 3 is equal to 6, 5 times 1 is equal to 5, is a group. So, let's determine if this set here together with the operation multiplication is a group. Now, for it to form a group, the first thing, of course, doon sa example number 1 natin kanina, alam kasi na natin na yung addition is a binary operation on the set of integers. Now, ganun din ba ang multiplication is multiplication, a binary operation on the set of integers? Meaning to say that if you have two integers, for example, the product is also an integer. Ganon. So, para malaman natin kung yung multiplication is a binary operation on the set of integers without further writing, without writing it on this board, isipin natin na kung meron ba tayong dalawang integers, for example, say A and B, for any two integers, A and B, ang product ba nila, A times B, is also an integer, say C. The product of A and B is C. Ang tanong, itong C ba is also an integer? Okay, so, of course, yes. The answer is yes. For any two integers, the product is also an integer. Therefore, we can say that this operation here, multiplication, is already a binary operation. So, binary operation na siya. So, punta na tayo dun sa properties ng group. What are the properties? Associativity, we have the existence of an identity element, and the third is the existence of an inverse element. So we have the first property is associativity. So, multiplication is associative. This operation, binary operation, is associative if for every A, B, and C elements of the set of integers, A times B, the quantity, times C, is equal to A times the quantity of B times C. So, for multiplication to be associative, kailangan i-satisfy niya itong equation na to. Now, we will use the same values for A, B, and C as we did dun sa example number 1 kanina. So, we have let A be equal to 1, B equal to 2, and C equal to 3. Okay? So, let's substitute the values of A, B, and C dito sa equation na to. So, we have 1, the quantity of 1 times 2 times 3 is that equal to 1 times the quantity of 2 times 3. So we have 1 times 2 is 2 times 3 is that equal to 1 times 6. So we know that 6 is equal to 6. So, meaning to say that this operation, binary operation multiplication, is associative. So, therefore, the first property is being satisfied. Now, let's proceed to the second property. And the second property is existence of an identity element E. Nag-exist ba yung identity element in the set of integers with respect to our binary operation multiplication? So, para makita natin yan, so we have, again, for the definition of the identity element, for all A element of the set of integers, yung ating A times E is equal to A. A times E is equal to A. So we have E is equal to A over A. Okay? And of course, although this expression here is equal to 1, however, it's not equal to 1 if A natin is equal to 0. Diba? Kasi kapag yung A natin is equal to 0, then we have 0 over 0 here. And 0 over 0 is an indeterminate form. And we don't want that to happen. So, nagiging 1 lang itong A over A kapag yung A natin is a non-zero integer. It's a non-zero integer. Pwedeng negative 1, so we have negative 1 over negative 1. Pwedeng 5, so we have 5 over 5. Pwedeng negative 3, that's negative 3 over negative 3, but not 0 over 0. Therefore, sabi kasi ng existence ng identity element for all. No, ang ating quantifier is for all. So lahat daw ng integer meron siyang identity element in the form of A over A. However, that is not applicable for A equal to 0. Okay? For A equal to 0. Therefore, we can say that hindi lahat, although hindi lahat ng integer na to pwede natin isulat as A over A. Hindi lahat ng integer A pwede natin siyang isulat in the form of A over A. It is good for 1, 2, 3. For 1, 1 over 1. For 2 is 2 over 2. For 3 is 3 over 3, and so on and so forth. And on the left of 0, we have negative 1. Negative 1 over negative 1. Pwede natin siyang sulat. Negative 1 over negative 1. For negative 2, negative 2 over negative 2, but not for 0. Because 0 over 0 is an indeterminate form. So, hindi ito check. So, wala. Hindi ito not satisfied. Not satisfied. Okay. And since not satisfied yung second property, pwede rin sabihin na yung third property, existence of an inverse element, hindi rin siya satisfied. Not satisfied. Okay. Since only one among the three properties of a group is satisfied by this set together with the binary operation multiplication, that means to say that this set here with respect to multiplication is not a group. Kasi for it to be a group, it must satisfy the three properties. Associative property, existence of an identity element, and existence of an inverse element. Okay? Now for our third example, we will involve modulos. Okay. For our third example, ang set natin is, say, Z sub 4. Okay, Z sub 4. And our operation is addition. Now, is Z sub 4 together with the operation addition, that's addition, this is not already the usual addition, but this is the addition modulo 4. So, is this set together with this binary, this operation, addition modulo 4, a group? Is it a group? Now, to show that this is a group, we know that this of 4 is a set whose elements are 0, 1, 2, and 3. So this of 4 has elements 0, 1, 2, 3. Now, to have a better grasp of what it means, okay, about this of 4, let us construct a K-list table. We call it the K-list table. So we have since this set here has exactly 4 elements, so we have addition. On this part, we write the operation. Then we have 0, 1, 2, and 3. Then we also have 0, 1, 2, and 3. Now, let us add this entry against this entry. So we have 0 plus 0 is, take note, the operation is addition modulo 4. So 0 plus 0 modulo 4, 0 plus 0 modulo 4 is equal to 0. 0 plus 1 modulo 4 is 1. 0 plus 2 modulo 4 is 2. 0 plus 3 modulo 4 is 3. 1 plus 0 modulo 4 is 1. 1 plus 1 modulo 4 is 2. 1 plus 2 modulo 4 is 3. And 1 plus 3 modulo 4 is 0. 2 plus 0 modulo 4 is 2. 2 plus 1 modulo 4 is 3. 2 plus 2 modulo 4 is 0. And 2 plus 3 modulo 4 is 1. 3 plus 0 modulo 4 is 3. 3 plus 1 modulo 4 is 0. 3 plus 2 modulo 4 is 1. And 3 plus 3 modulo 4 is 2. So we have already completed the table for zeta 4 with respect to the operation addition modulo 4. Now, observe that when we take any two elements of zeta 4, the addition, the sum modulo 4 is always found in the set. Meaning to say that no entry on this table which is not found in zeta 4. Lahat ng sum 0, 1, 2, 3, 0, 1, 2, 1, 2, 3, 0, 2, 3, 0, 1, wala kang makitang entry dito sa table na to na hindi makikita sa zeta 4. For any two for any two elements of Z sub 4, di ba? For any two elements of Z sub 4, yung kanilang sum, modulo 4, is, say C, is an element of Z sub 4. Making this addition, therefore, this addition modulo 4 is a binary operation on Z sub 4. So, yan muna, bago tayo pupunta sa properties ng group, kailangan muna natin i-test kung yung operation na yon doon sa Z sub 4, doon sa set na yon, is a binary operation. And through this table, the K-list table, na ipakita natin na itong addition modulo 4 is a binary operation on Z sub 4. Now, we will proceed to the properties of a group para maipakita naman natin na yung set na yon, Z sub 4, with respect to this binary operation, addition modulo 4, is a group. Okay, the first property is associative property. Associative property. Okay, so this operation, binary operation, is associative if for all A, B, and C elements ng Z sub 4 we have A plus P, the quantity, modulo 4, plus C, modulo 4, is equal to A plus the quantity of B plus C modulo 4. Okay? So, kailangan ito is equal to dito. Now, using this table, the K-list table for Z sub 4 with respect to addition modulo 4, for example, we let A equal to 2, B equal to 3, and C equal to 1. So we have 2 plus 3 modulo 4 plus 1 modulo 4 is that equal to 2 plus 3 modulo 4 plus the quantity plus 1 modulo 4. Okay? So what is 2 plus 3 modulo 4? 2 plus 3 modulo 4 2 plus 3 modulo 4 is 1 plus 1 modulo 4. Is that equal to? We have 2 plus modulo 4. 3 plus 1 modulo 4. 3 plus 1 modulo 4 is 0. Next, we have 1 plus 1 modulo 4 is 2. And that is equal to 2 plus 0 modulo 4 is, of course, 0. Okay? So, with that alone, we can say that the addition modulo 4 is associative. Now, let's proceed to the second property. Now, our second property is existence of an identity element. Thus, the identity element exists in the set Z sub 4. We will show that. So, for all A element of Z sub 4, A plus E modulo 4 is equal to A. A plus E modulo 4 is equal to A. So if we let A equal to, say, 3, then by substitution, we have or, kahit na hindi tayo mag-assume ng value for this A, pwede naman natin siyang resolve yung E. Solve natin yung E, so we have E is equal to 0. So, E is equal to 0. Right? So, yung 0 ba? Element ng Z sub 4. Okay, yes. So, ibig sabihin, nag-exist yung identity element sa Z sub 4. So, the second property is satisfied. Now, for the third property, the existence of an inverse element B. Anong sinasabi nitong property na to? For all A element ng Z sub 4, yung ating A plus B modulo 4 is equal to 0. The identity element in Z sub 4 with respect to addition modulo 4. So, ano yung B? B is equal to, of course, using our usual arithmetic addition. So, we have negative A. Ang B natin ay negative A. But take note, wala namang negative na values dito sa ating Z sub 4. Meaning to say, kapag the negative of A with respect to addition modulo 4, nangyayari lang yan kapag ang isipin natin is when we add any two elements in Z sub 4, ang sum niya modulo 4 is equal to 0. So, mapapansin natin na kapag kinuha natin yung sum ng dalawang numbers na to, ang resulting sum modulo 4 is 0. Ito yung mga resulting sums. 1 here, 1 here, 1 here, 1 here. For this, we have, this entry here is intersection of the two elements, 0 and 0. Meaning to say that the inverse of 0, so negative A, the inverse of 0 is 0. Let's note that as negative 0. Ang inverse ng this negative here is pertains to the inverse, no? The inverse with respect to addition modulo 4. So, ang inverse of 0 is 0. Ang inverse of 1 is 3. The inverse of 2 is 2, and the inverse of 3 is equal to 1. Okay, the inverse of 0 is 0. Why? Because when you add the two entries, the two elements of zeta 4, the sum modulo 4 is the identity element 0. Now, when you take the sum of 1 and 3, their sum is 0 modulo 4. When you take the sum of 2 and 2, of course, the sum is 0 modulo 4. And of course, the inverse of 3 is 1 because when you take the sum modulo 4, it is equal to 0. So, 0 plus 0 is 0, 1 plus 3 is 0, 2 plus 2 is 0, and 3 plus 1 is 0. Okay? So, meaning to say that each of the elements of zeta 4 has an inverse. So, meaning to say that the third property is being satisfied. Now, since all the properties of a group are satisfied by this set, zeta 4 with respect to addition modulo 4, we can say that this is a group. And since it is a group, we can denote that using this symbol. Now, what if I'm going to change the operation from addition modulo 4 to multiplication modulo 4? What happens to the set with respect to multiplication modulo 4? Will it become a group? So, we will change from addition modulo 4 to multiplication modulo 4. So, from addition to multiplication modulo 4. Okay, so let's have some calculation here. So, 0 times 0 modulo 4 is 0. 0 times 1, because, of course, when a number is multiplied by 0, no, the product is always 0. Kahit modulo 4 yan. So, 0 times 2 is 0. 0 times 3 is 0. Next, 1 times 0 is 0. 1 times 1 is 1. 2 times 1. 1 times 2 is 2. And 1 times 3 is 3. 2 times 0 is 0. 0 then. 2 times 1 is 2. This is 2 times 2 is 4. Modulo 4 is 0. 2 times 3 is 6. Modulo 4 is 2. 3 times 0 is 0. 3 times 1 is 3. This is 3. 3 times 2 is 6. Modulo 4 is 2. And 3 times 3 is 9. Modulo 4 is 1. So, is it a group? Is it a binary operation? Now, is it a binary operation? Yes, it is a binary operation. The multiplication, this operation here, modulo 4, is a binary operation on 4 zeta 4. Okay. Now, the next question is, does it satisfy the 4 properties of a group? So, after we are done with the binary operation, or testing whether the operation defined is a binary operation, then we proceed to the properties of a group. The first property is the associative property. Okay, the associative property. What do you think? So for associative property, we have for all A, B, and C elements of system 4, the product, the quantity times C is equal to A times the quantity of B times C. So if A is equal to, for example, if A is equal to 1, B is equal to 2, C is equal to 3, so we have 1 times 2 is 2 times 3 is not equal to, we have A is 1 times B times C is 2 times 3 is 6. So 6 is equal to 6. So the first property is being satisfied. Now the second property is the existence of an identity element. So we have second property, existence of an identity element. Thus the identity element exists. So for all A in Z sub 4, A times E is equal to A. Okay, so we have E is equal to A over A. Again, we cannot, all the elements can be written in the form of A over A except for 0, because when you say A is equal to 0, then A becomes 0 over 0, and that is indeterminate form. So the second property is not satisfied, and since not all the elements of this 4 can be written in the form of A over A, then it implies that not every element in this 4 has already an inverse. So the third property, existence of an inverse element, is also not satisfied. Not satisfied, and this is also not satisfied. Since only one among the three properties is satisfied by this set, this of 4, together with the binary operation, multiplication modulo 4, then we can say that this is not a group. This is not a group. Okay? The last objective of this lesson, that is a discussion on the isomorphism, what is isomorphism, will be discussed next part of this video. And that ends our lesson for today. Thank you.